Hello, today we are going to learn about the sine and the cosine functions. A few objectives we have today are to draw a given angle on our Cartesian coordinate system and find its reference angle, understand terms involving angles such as initial position, terminal position, standard position, coterminal angles, and reference angles, and C, understand sine and cosine as functions extending beyond right triangles, recognizing the graphs of the parent function sine x and cosine x and the transformations of these parent functions. So we're going to back up to finding the hypotenuse of a right triangle. Hopefully we remember that if we have a right triangle, we can use the Pythagorean theorem to come up with the third side. So in this case, it doesn't matter what you call a and b, 4 squared plus 3 squared equals c squared. 16 plus 9 equals c squared. 25 is equal to c squared, so therefore c is equal to the square root of 25, which is 5. I'd like you to pause the video, try this one, make sure you can do the Pythagorean theorem. All right, I hope you were able to get your answer, which was 17. All right, we're going to look at sine and cosine functions for degrees between 0 and 360. Some of us may remember SOHCAHTOA. We're going to concentrate on the SOHCA today. So sine is the opposite leg over the hypotenuse, and cosine is the adjacent leg over the hypotenuse. All right, so if we were just to ask what is sine of A, we write down sine of A. Please make sure you're always putting a letter or a variable after you write sin. All right. Then we say, okay, well, sine was opposite, so the side opposite angle A is going to be the 5. So we're going to write 5 over, and the hypotenuse is the 13. And so my answer is just 5/13. I do nothing with that. That is simply my answer. If I have cosine, again, make sure you write COSA, don't forget the A. Cosine now deals with my adjacent side, so the side right next to A is the 12 over your hypotenuse, which again is still 13. All right, now we're going to take them from the right triangles and we're going to stick them in our coordinate plane. So I'm going to take this triangle here. I'm going to drop down the hypotenuse and make it a right angle. Then I know from here to here is x, and from here to here is y. And so that's why this point right here is the point xy. So now if I were asked you to find cosine of this angle right here, you would take the x, because that's adjacent to it, over the hypotenuse, which is r. Similarly, if you're looking to find y, or sine theta, you take the opposite angle, opposite side from the angle, so you have y over your radius, or your hypotenuse, which is r. A lot of times you just have to remember that anytime we're talking about cosine, we want you to think x. Anytime we're talking about sine, we want you to think y. All right, so from yesterday, we talked about angles and finding the reference angles. So let's see if we can find a connection. If I draw a 147-degree angle, that'll put me in the second quadrant. And I am more interested in my reference angle. So that is my reference angle. And I want to figure out what that measures. So all I have to do is realize that if I were to go all the way across, that would be 180 degrees. And so if I take 147 away from 180, I am left with 33 degrees. So that is my reference angle. So now I want us to go to our calculators and check some things out. Okay, so the first thing you need to do is make sure your mode is in degrees. So you see I have to change mine. So I went to mode, I arrow over degrees, and I hit enter. Okay, now I'm going to check out what cosine of 147 is. So cosine of 147, hit enter, and I get that as negative 8.83. We're going to round up to 9. And I'm going to stick cosine of 33 while I'm here with my calculator and hit enter. And notice I get the same decimal, I just get positive instead. So let's record that information. Negative 0.84. I gotta look back. Oh, 83. 839. And so cosine 33 was positive 839. If I do a similar thing with sine, so I do sine of 147 and I hit enter, and I do sine of 33 and hit enter, notice this is the exact same answer. It's not even off by a negative like cosine was. So record those, 0.545. So how do these compare? Cosine switches signs, but sine stays the same. Okay, well let's try an angle in the third quadrant. So 195 would put me a little bit over 180. And so my reference angle right here would be 195 minus 180, which is 15. 15 degrees. Okay, so now if I go and check, and I'm going to let you, what is cosine of 195? So cosine oh, got to clear this here. Cosine of 195 versus cosine of 15. Again, this one, cosine switch signs. So let's check what sine does. Sine of 195 versus sine of 15. This one switches signs. So let's put this information down so that we have it in our notes. So I have point. Okay, so you can see I get those numbers in there, and then how do these compare? Both the sine and the cosine change signs. All right, one more quadrant to investigate. Let's look at our fourth quadrant angle, which is 305 degrees. 305 is going to leave me with the reference angle. So I take 350, or 360, subtract 305, and my reference angle is 55 degrees. All right, so now let's go figure out what cosine of 305, sine of 305, all of those answers are. All right, so cosine is 0.574, and notice that cosine of 305 and cosine of 55 is the exact same decimal, but sine went and switched. So before, cosine switched and sine stayed the same, but now cosine stayed the same and sine switched. So let's look at all four quadrants and put these together. All right, so sine and cosine are both positive in the first quadrant. All right, in the second quadrant, we found out, I'm going to put cosine here and sine here. In the second quadrant, we found out that cosine was negative, but sine was positive. In the third quadrant, we found out that both of those were negative. And in the fourth quadrant, we found out cosine was positive and sine was negative. All right, so this should take us back to when we first started plotting points. All right, we know both the x and the y in the first quadrant are positive. If we had to plot -2, +1, we know we would be in the second quadrant. So therefore the x is negative here. So that's why cosine is negative here. Sine is positive because y is positive. If we plotted the point -2, -4, we would end up in the third quadrant. Again, cosine is the x, so you think if x is negative in this quadrant, so's cosine. If y is negative in this quadrant, so's sine. And in the fourth quadrant, we can see cosine's positive because if you were to plot an x value, it would be positive here. And if you were to plot a y value, it would be negative here. So that is why cosine is positive, sine is negative. Those numbers I put in there are just random examples of where you'd plot points.